Well, hello friends. Welcome back to the program. Today we're going to play another game of FIXME Roulette. And this is the game where we grep for FIXME and shuffle the output so that we get a random one. And seems like people really like the format lately, so happy to keep making more of these videos because they are a fun challenge. So we're going to grep actually for to do and FIXME this time because somebody pointed out on Discord that we have like almost 1,000 to-dos as well, so it's only right that we include those. Anyway, today's FIXME or to-do is going to be in libcore file. Okay. Libcore file .cpp line 456. Implement utime ns and use it here. Okay, so we're using utime, which is, it doesn't have nanosecond precision. So I guess that's the issue here. And we are in file, copy file. So this is a helper used by, wait, who calls this? Core file, copy file. Oh, CP calls it. Cool. Okay, so we can test this with CP. So this is specifically when we are preserving timestamps. So I guess this is. Wait. Oh, I have some unrelated changes. Let me fix those up. And actually, let me build a fresh disk image. So yeah, so we should be able to test this with CP and just setting it to a mode where it preserves timestamps. And then I think if I understand the bug correctly, we will observe that the nanosecond part of timestamps is not preserved when copying a file. So if we make a file foo, then it will have this time stamp where we can't see the nanoseconds. Okay. Step 1, fix the stat program so it prints out the nanosecond part of timestamps. Just your standard issue yak shaving. So print time. Right. How does this work? So we're passing the sta time, which is a macro. Wait, what? Oh, the stat. Struct stat is actually has time specs in it, but these are macros. That's kind of weird. Okay, so we can just time spec has nanoseconds. Yeah. Right. So we just need to wait, what was the name of it? Atim, matim, and satim. So we just need to pass atim, matim, and satim instead of a time, m time, and c time. And then we say that this is a time spec. We can still do this, or this rather, but we'll just tack these on, the nanoseconds on at the end here. And then we don't have to get clever in any way. And I think it'd be nice if that just worked. Okay, so foo is still there. Yeah, stat foo. But the nanosecond part is 0. That's not super helpful, actually. Okay. Oh, wait, I bet that's because it's an ext2 file system and we didn't implement nanosecond timestamps for ext2 inodes. That's one of many things that we need to do in the ext file system implementation. But what if we just go to /temp instead? Because that's our own file system. We are the bosses there. So we make a new foo and then stat that foo. But it also has zeros. Okay. Why? There's no reason for that to have zeros. tmpfs inode. Update timestamps. Well, this API is suspicious because the API takes time t, which is a number of seconds. So it doesn't even, we don't even have an API for setting the timestamp with nanoseconds. Cool. Okay, so this is gonna this is gonna take some effort. It seems like. So wait, we should probably change this API then to. We can take a time spec, or we can also just take like an act time or a time. Maybe time is the better one because that's like our own time thing. We don't need to use POSIX types internally in the kernel. POSIX is just for user-facing stuff, or like user space-facing stuff, right? Kernel APIs. So maybe we can just search for this and then replace it with time. Or maybe I could also use that. There's this fancy change signature refactoring thing, which I don't use very often. But let's try to use it. Come on, C-Line. Let's see your features. Okay, so let's try this. Change the signature here. Oops. Okay. Now, will this work? Be nice if it did. Okay, well, it finished. I mean, if it builds, it might work. That'd be nice. And then, of course, we can't just store these the way that they are. Now I'm thinking like maybe we should change the API in one commit. Okay, let's commit that stat change that we did first of all. So stat show nanosecond part of file timestamps. Okay, and then maybe can I convert this to a time spec? Is this the nice way to do it at first? Is this actually what I want to do though? Like, I feel like what I really want to do is, wait, what is this thing? Inode metadata. Wait, hold on. The tempfs inode has inode metadata, and inode metadata also has second only timestamps. Cool. So let's change these to time as well. Like that. And now I guess we can just do this, right? Because, or rather, it's not enough to do that, but we can do to time spec, I think. And we need to include act time here. But yeah, I think there's a to time spec, right, that we can use. Oops. Yes. So that's good. And then now a million things will probably break because I did this. So we'll just have to try and build, see what happens. Yeah, lots of stuff. A time value or Let me build with K0 just so it runs in the background. And then, okay, so what do we do here? I'm looking for invalid timestamps in the ext2fs update file. So we can't quite say this anymore. I guess we can do this. To time spec tvnsec. That's so clunky. But yeah, whatever. And then, yeah, so our implementation of ext2, we don't support the nanosecond component yet. So we are going to truncate in ext2. But that's okay. We'll survive. This we'll have to expand on that support when we eventually get to ext3 and ext4 and so on. Okay. Oh, actually only 20 files that didn't build. It shouldn't be that bad to get this working. Okay, time management boot time. Wait, what's wrong with that? Oops. What is that? Returns a time t. Cool. And it's always assigned to m time. So I think maybe maybe the easiest thing to do here is just make it return time. And that's a boot time. So what is RGC boot time used for? Only for this. Cool. Yeah, so we're just gonna go ahead and make this a little nicer. Time. From, is this from seconds? Is that what this is? From seconds, S boot time. I saw you. Oh wait, that's what I just did. I'm not confident about using that on a timestamp. Maybe there's some nuance there. So I'm gonna go ahead and take the easy cheesy way out and do from time spec and just pass in a time spec like that. Okay, and somebody correct me if I'm wrong or if it's overkill or whatever. Okay. And then what was I looking for? Boot time, right? M time is time management boot time. And then that assignment just works. Yeah. Okay. .c time now. Click. You don't like these because okay, get time of day 2 truncated seconds. Okay, right, yeah, of course that returns the seconds, but get time of day gives you a time, so you can actually just not truncate. So it seems like we are just truncating nanoseconds all over the place in the kernel. So it's actually good that we got into this. Is this the same type of problem in this other file, I guess? Yeah. Time t. Oh yeah, just use auto, bruh. Problem be gone. File system inode. Let's see. Wait, what is this? This is time. Oh yeah, it's just truncating again. Sure. Don't truncate. And maybe just call this now instead, because it's now. That's what we usually call that. Okay. And then ext to inode. D time. Okay. So here we have to do time from time spec Then we'll just make a little fake time spec that has 0 nanoseconds on it. Okay. And then we have other stuff like sysfs inode. Update timestamps. Wait, what? Virtual file system 415. More truncation. Maybe we can just search for this. 2 truncated seconds. Kernel file system. Yeah. Just search for that and find more places. Oh, wait, no, that one we wanted to be like that. Okay. inode file 99. Truncate. This API called truncate should not truncate the dang timestamp. What else we got? Process property inode. It says traits modified time. You don't like that because modified time is a time t. But we have a time there, so we can actually do this. Ha. Okay. This is going pretty good so far. Just a bunch of build issues to fix up. What is that? ISO 9660 CPP. Or maybe I should be in the inode. Wait, am I in the right place? 184. Parse numerical. No, okay. Recorded at. Oh, this just wants to be a time t. Not auto. Time. Auto. Time. From time spec. Let's do this here as well. Okay. Does that work? I guess D time can't be 0. Yeah, there we go. Plus equals boot time. Oh, somebody was using the boot time. Well, we can always do timespec.tvsecond. It's okay. Sysfs node update. Sysfs inode, maybe it was. Yeah, update timestamps. These are not used for anything in the sysfs. Fatfs inode. Fat inode. Okay. Yeah, it's just something that returns a time t. We'll do this thing again. Like that, like that, like that, like that. Haha. PTY, time of last write. We're getting there. Not many left, I think. That's also a time t. No big deal. Maybe there should be time from time t. Maybe. Virtual file system. Wait, what? Utime omit? What is that? Utime n is at. So this is the syscall that we wanted to use in the original FIXME. And if tv nsec is utime omit, wait, what is this? If the tv nsec field is utime emit, then the corresponding timestamp is left unchanged. Oh, I see. So it's like, don't update that timestamp, because utime n is at updates two timestamps at the same time, a time and m time. But if you set the nsec field of one of them, or both, to utime omit, I guess, then we don't update that one. Right. So if it's not utime omit, we should just pass in time from timespec. A time. And time from timespec, m time. And these want to be just time. Okay, that's good. And yeah. I think there was a truncation going on here too, right? Yeah, it's truncating to seconds here as well. Yeah, so much truncation everywhere. Update timestamps a time. Who are you and what are you doing to my a time? Oh, this is u time. That's okay. Here it's okay to truncate because this is the syscall that does truncate. Okay. Is that it? Is that... Do we build? Can we build, please? Okay, we can build. Can we run, I wonder? Or did we break some terrible thing now? Okay, we're booted. Mellow. Stat mellow. Okay, yeah, ext2 is not going to work, but touch mellow, stat mellow. Hey, look, it's timestamps. Touch stat. Touch mellow, I gotta do. Yeah, it's updating. That's super cool. Wait, should the M time be updated when I touch? Shouldn't the M time be updated? Wait, what the heck? Yeah, when I'm updating, when I touch in my home directory, it updates the M time. But in temp, the M time stays the same. But the A time is updated. Say what now? So yeah, in the home directory, A time and M time get updated. That's what I would expect, I guess. So what are we doing in tempfs update timestamps? Oh, that doesn't look right. Let's see who did that. Oh, look, it's some idiot. Dang it. I guess I messed that up. Okay. That's definitely something we can fix. Although let's do that separately. So first here, let's just do a big commit. Kernel use time for inode metadata timestamps instead of time t. Before this change, we were truncating the nanosecond part of file timestamps in many different places. Yes. And then we fixed this little stupid typo here. And we say kernel tempfs, I guess. Update mtime. Actually, update mtime. Update mtime instead of ctime when asked to update mtime. Yeah, that's my bad. Okay, and then can we finally see this working? So if you go to temp, touch foo, stat foo, I forget where we started even. So now we have the file foo, right? And now I want to copy the file, and I wanted to see if it fails to preserve the timestamp. So if I cp normally foo bar, stat bar, then bar has a fresh new timestamp, right? So this is like the time when I created bar, time when I ran cp. But if I use cp-p for preserve, I think, yes, here is the bug. This is the FIXME that we were supposed to get to. Now we can actually see the problem. Okay, so what we want to do is we want to use utime ns so that we preserve the nanosecond part of the original timestamp, which means that we have to use utime ns at. I don't think we have utime ns. Utime ns. No. Oh, there are two FIXMEs about that in the same file. I guess we get two for the price of one here. Okay, so yeah, the second one looks identical to the first one, so that will be an easy fix. Okay, so how does utime ns work then? Utime ns at takes what exactly? Utime ns at. I just want to see the API. Okay, a derf, a path, 2 time specs, and a flag. Okay, well, I don't have any flags, I guess. What kind of flags does it want? Flags can be at symlink no follow. Okay, well, we can just pass through the kernel already has utime ns at, so we don't need to worry about that. So I guess I just call utime ns at, and then a directory file descriptor. So we just use at fdkvd so that it's relative to the current working directory. And here we need to pass in some time specs. I'll just say times, and some flags. And then the times is going to be struct time spec times 2. And we will have these fellas, I think. So actually, we can just copy the whole things. Yeah. Right. Is that simple? So okay. I think that's it. And then exactly the same thing here. Kluk. Okay. Will this work? We will find out. Go to temp, touch hello, stat hello, copy. Oh, look at that. Almost on the edge of that second. And copy hello to buy. Okay, stat buy. And it has the cool edge of a second timestamps. Very cool. Okay, so, oh, look at the date. 221122. How pleasantly symmetric. Okay, so what do we do with this? We commit. So libcore, use utime and as at in core file to preserve nanosecond timestamps. This takes care of 2 FIXMEs. Oh-wee. Oh man, this seemed like it was going to be easier at first, but then we had to go on a little bit of a journey there. Okay, but we made it. And this is really good, actually. Now we have discovered, or we did discover that nanoseconds were just being truncated left and right, and we fixed it. Of course, it's still not fixed here, so you don't have nanoseconds in the home directory, but that's a FIXME for another day. They should be working in temp now, so that is very cool, and they are preserved when you copy them with CP. Cool. So that's 2 FIXMEs down. Just another day's honest work. This will be the end of the video, so if you made it here, thank you for watching, for hanging out. I hope that you saw something interesting, and I hope you enjoy the FIXME Roulette format. It's pretty fun, so I guess we'll do more. Anyways, see you all next time. Bye.